Hello, this is the Lesson 3 homework for Module 3 for 5th grade, and we're going to be using rectangular fraction models to add fractions. So I'm going to represent each of these fractions, 1/4 and 1/3, with a rectangular model. So 1/4 and 1/3. And what's important about this is that one fraction I'm going to represent with horizontal lines, 1/4. Doesn't really matter which one. As long as on the other one, I do the opposite. So 1/3, I'm going to represent with vertical lines. The next step is to overlay the lines from one area model onto the other area model. So I'll take my thirds and put them on my fourths, and take my fourths and put them on my thirds. And from that, I've now made a common denominator in each of these fractions. So now I have 12ths in each one. And 1/4 is equivalent to 3/12, while 1/3 is equivalent to 4/12. Now I can add them together. 3/12 plus 4/12 equals 7/12. And the directions say to simplify your answer, but you can't get to any simpler terms than 7/12. So we are good to go. If I look at the next problem, 1/4 plus 1/5, I start the same way, creating an area model for each one. Like before, I made one of the area models horizontal and one of them vertical, so now I can overlay the vertical on top of the horizontal and vice versa. Now I can write the new fractions that are equivalent to the original fractions underneath. 1/4 is equivalent to 5/20, and 1/5 is equivalent to 4/20. And when I add them together, I get 9/20. Again, that's the simplest form that I can have that fraction in. For the next problems, I'm not going to explain each step. Hopefully by now it makes sense, but I'll go ahead and draw the area models and display them here. 1/4 and 1/6 become 6/24 and 4/24. When we add those together, they become 10/24, which can be simplified because both the numerator and the denominator, or the top number and the bottom number, are divisible by 2. So the end result is 5/12. 1/5 and 1/9 start off looking like this. And when we overlay the lines of one onto the other one, they become 9/45 and 5/45. So old school style was just to multiply the numerator or the denominators by the opposite number, or the other fraction's denominator. And while that's fine, it's really important for kids to be able to visualize and create a visual model of these fractions because that leads to true understanding and a deeper understanding of what they're doing. When I add 9/45 and 5/45, I'll get 14/45. Hopefully this has been helpful with Lesson 3, and the kids can finish the back page on their own and understand what to do with the word problem. Have a great evening.